This is the fifth lecture for section 2. This one is on conversions. By conversions, what I mean is changing the units of a number without changing the amount. An easy example, I can tell you to get 6 donuts and you'll come back with this, or I can tell you to get half a dozen donuts and you come back with this. The amount of the donuts doesn't change, but the unit does. So we can convert from 6 donuts to half a dozen donuts, and this gives rise to the ever-popular 6 of one, half a dozen of the other. You know how to do this, and to prove it, I'm going to give you a problem that you will be able to answer very easily. You have a stick which measures 18 inches. How long is this stick in feet? Stop, figure out the answer, come back, and then we're going to go through it. Go. The answer is 1.50 feet. If I were to ask you, how did you get this? You would go, it's really easy. You take the 18, you divide by 12, you get 1.50 feet. But if I then say, why did you do it that way? You're very likely to look at me and go, because that's what you do. It all comes back from this, 12 inches equals 1 foot. These two things are equivalent. This is an equivalency statement. So what you did was you took 18.0 inches, multiplied it by 1 foot over 12 inches, the inches cancel out, and you get 1.50 feet. As a matter of fact, you can do this so well, you do this without even thinking. But you're going to have to think to do the other conversions, at least initially. So let's start with the equivalency statement. 1 foot equals 12 inches. Since they are equal, if I happen to take 1 foot and divide it by 12 inches, that equals 1. So multiplying by this fraction is the same as multiplying by 1. The same is true if I go 12 inches divided by 1 foot. We call these fractions, this one and this one, conversion factors. So what we did here was take the 18.0 inches and multiply it by a conversion factor that allowed the inches to cancel out. Now it's important to note that conversion factors have infinite significant figures as they are defined. So the significant figures for your answer are determined by the number you are converting from. Now you do the same thing for the metric system, only it happens to be easier because the conversion factors are always the same, and they're always going to be some factor of 10. And you remember that you need to know that 1,000 milli-x equals 1x. So for example, 1,000 milligrams equals 1 gram. 100 centi-x equals 1x, 100 centimeters is 1 meter, and 1,000x equals 1 kilo-x. For example, 1,000 liters is a kiloliter. And if you can do conversions with these three, you can do conversions for any metric conversion, and I will give you the equivalency statements for all the others. So for example, suppose you have a bottle filled with 525 centiliters of Kool-Aid. How many liters of Kool-Aid are in this bottle? Well, you start with the equivalency statement. 100 centiliters equals 1 liter. Since we want to get rid of the centiliters, we're going to use the conversion factor of 1 liter divided by 100 centiliters. We take the 525 centiliters, multiply it by the conversion factor, and we get 5.25 liters. We started with 3 sig figs, we ended with 3 sig figs. Also note, the digits for a metric conversion never change. So if you have 525 centiliters, your final answer will have 525 in it in that order. So the steps for a conversion are pretty simple. There are 4 of them. 1. You need to identify the equivalency statement. For example, 1,000 milliseconds equals 1 second. 1,000 liters equals 1 kiloliter. Number 2, you set up your fraction or your conversion factor from the equivalency statement so the unit you're converting from will cancel out. Multiply the original value by the conversion fraction. Multiply the original value by the conversion fraction. The units should cancel out that you want to get rid of. Your sig figs will be the same, and now you can relax. You're done. Well, almost. You do need to go, does the answer make sense? So for example, what we have here is a picture of a gram and a kilogram. Now knowing that, suppose I have 250 grams, I want to know how many kilograms that is. I will assure you that you will come up with one of 2 answers. You'll either come up with 0.2500 kilograms, or you'll come up with 250,000 kilograms. Which answer makes sense? Well, if this is 1 gram, and you have 250 of these, do you think then you're going to have 1/4 of this, the kilogram, or you're going to have 250,000 of these equaling 250 of those. And it's pretty easy to see that the 250,000 is absurd, so the correct answer must be 0.2500 kilograms. Make sure the answer makes sense. I have 3 examples for you, and then this video will be done. So here's the first one. You're going to travel 24.5 miles. Notice 5 significant figures in the 24.500. How many feet will you be traveling? And I'll even remind you that 1 mile equals 5,280 feet. Stop, figure it out, come back, and we'll go over it. Go. The correct answer, 129,360 feet. Parenthetically, this has 5 significant figures. How do we get this? Well, we start with the example, and we identify the equivalency statement. 5,280 feet equals 1 mile. We set up the fraction from the equivalency statement, so the unit we're converting from will cancel out. We want to cancel miles, so we're going to go 5,280 feet divided by 1 mile. Multiply the original value by the conversion fraction, 24.500 miles, multiplied by 5,280 feet, divided by 1 mile. The mile unit cancels out. So now you can relax. You've got to have the correct answer. And you notice you get 129,360 feet. Okay, how about a second example? You're in Europe, you buy a bottle of Coke, and you notice that it has an energy content of 1.35 kilojoules. That's the metric unit, not calorie. How many joules is this? Stop, figure it out, and then we'll go over it. Go. And the answer is 1,350 joules. How did we get this? We identified the equivalency statement. 1,000 joules equals 1 kilojoule. We set up your fraction from the equivalency statement, so the unit converting from will cancel out. So 1,000 joules per 1 kilojoule. Multiply the original value by the conversion fraction, so 1.35 kilojoules times 1,000 joules divided by 1 kilojoule. The kilojoules cancel, so this means you have the answer, 1,350 joules. One final example. You have a piece of rope which is 345 millimeters long. How long is the rope in centimeters? Stop, figure it out, back, and see if you have the correct answer. Go. The correct answer is 34.50 centimeters. How did we get this? Well, there's really 2 ways to do this. I'm going to take you through both. The first, method 1, we know that 1,000 millimeters equals 1 meter. We want to get rid of millimeters, so the conversion fraction becomes 1 meter per 1,000 millimeters. So we multiply the 345.0 millimeters by 1 meter divided by 1,000 millimeters. Units cancel. We now have 0.3450 meters, but the answer is in centimeters. Well, we know it's 100 centimeters equals 1 meter. 100 centimeters divided by 1 meter be the correct conversion fraction. So we multiply 0.3450 meters by 100 centimeters divided by 1 meter, so the meters cancel. And you do that, and you get 34.50 centimeters. Just do it in a stepful fashion. Method number 2, we know that 1,000 millimeters equals 1 meter. We know 100 centimeters equals 1 meter. And you probably remember, if A equals B and B equals C, then A equals C. So if 1,000 millimeters equals 1 meter and 100 centimeters equals 1 meter, then we can state that 1,000 millimeters equals 100 centimeters. So we're going to use the conversion fraction of 100 centimeters divided by 1,000 millimeters. So when we plug this into the equation, we notice the millimeters cancel, and lo and behold, you get 34.50 centimeters, just like before. Either method is perfectly acceptable. So that's all there is to conversions. Now it's just practice. But to review, conversions allow you to change units, but the amount of the pre- and post-conversion units are equivalent. Conversion factors have infinite significant figures, and the pre- and post-conversion value must have the same number of significant figures. In a metric conversion, keep the digits. They don't change. Use dimensional analysis to ensure that you have the equation set up correctly. Units are your friends. If the units come out wrong, you set it up wrong. And lastly, and importantly, does the answer make sense? There are 4 steps. Write out the equivalency statement. Set up the fraction so units will cancel out the conversion fraction. Multiply the original measurement by this fraction. And relax. You've got it done. So now you can rest up and then come back and do the worksheets. In the next video, which is the last video of this section, we're going to talk about 2 ideas called precision and accuracy, and then we will move on to some real chemistry in section 3.